This is Algebra 2 with trig. We're working on 3b.2b, simplifying complex fractions. Complex fractions are when you have a fraction inside of a fraction. A complex fraction is a fraction that contains a fraction in its numerator or denominator. And or, really, and or, that type of or. The textbook shows two different methods for simplifying complex fractions. We're going to focus on method 2, since that seems to be what pre-calc teachers want. Okay? We talked about it since the first day that this class is for preparing for pre-calc. Okay, this method 2 is going to eliminate all the little fractions that are in these problems. So if you look down here, we're going to come up with a method that gets rid of all the little fractions. And then you add two numbers, and then you have your final quotient, which is an answer to division. What we're going to do is find the LCD by looking at all the denominators of the little fractions. The LCD, least common denominator. We're going to multiply the numerator and the denominator of the big fraction by the entire LCD. We're going to distribute this LCD to each of the terms. So let's come on here and try it. So we're going to look at the LCD, the least common denominator. What we do is we look at each of the denominators in the little fraction. And we notice that x is one of them. And x plus 4 is another one. So that would be considered your least common denominator. You don't have to write the x plus 4 twice. So now, following our directions, we're going to take this x plus 4, which is our LCD, and we're going to multiply it to each of the little fractions. And I'm trying to make it look obvious that I'm multiplying it to the top of every little fraction. You don't multiply a term to the bottom. You only multiply it to the top. Unless it's a fraction, and then it goes bottom to bottom, top to top. But this is, your LCD won't be a fraction in of itself. So now by taking your LCD and multiplying it to each of the terms, you are now going to cross out what you can. And cross out what you can. So now you notice each of the denominators disappeared. They all got eliminated. So we're left with 5 times x. We're left with 1 times x. And we have 2 times x plus 4. So that's going to give us 5x, x plus 2x plus 8, because you distribute that through. And your final answer, of course, is 5x, 3x plus 8. As we look at the next question, we're going to look for LCD. Now think about what your LCD would be. You're looking at each of the little denominators. So we have x as one of those little denominators, and we have x minus 5 as the other little denominator. So together, That is your LCD. There's no other factors that make up the denominators. So we're going to take that x minus 5, and we're going to multiply it to every term in this problem. So then you can start eliminating what you have. So the x minus 5 is going to cross out with its denominator, and that leaves you with the 6 times the x. The x's cross out, and you're left with an x minus a 5. Then you have your fraction bar. Your x's cross out, and you're left with 3 times x minus 5 minus 2x. So that helps dramatically about getting rid of all those other denominators, making the problem look so much easier. Now we got to collect our like terms. We have 3x minus 15 minus 2 more x, which is 7x minus 5 and x minus 15. A common mistake here is to think that you can reduce the 5 and the 15. You cannot reduce the 5 and the 15. If it was just 5 and 15, that we could reduce. If it was 5x over 15, that we could do. But if it is 5 plus x over 15, you cannot reduce that. Because of the plus, you cannot reduce. You can't get to just those terms. Now, to make things confusing, if this was 10 plus 5x over 15, or any multiples where you can pull out a GCF, that you can reduce because it's 5 times something, and it's just the 15. So this would be 2 plus x over 3, which is actually the same thing as 2 over 3 plus x over 3. Whole bunch of mathy stuff. All right, so we move on to our next example. Now this one has a factor in it, so we might want to rewrite it so we can figure that part out. So we're going to take the 3 and the x minus 4 minus 6. How do we factor? This is called the difference of two squares. So we would say x minus 4, x plus 4. And it's a long fraction bar. Then on the bottom is still your 3x plus 4 and 1 over x minus 4. So now if we look for the LCD, we have an x minus 4 as a term. It happens to be in a couple of them, a few of them. We have an x plus 4, that's another denominator, and that's in a couple of them. You don't have to write it for every time it's in there. So if that's our LCD, then we're going to multiply the top of this one by our LCD and top of this fraction by our LCD. I like to write it on both sides instead of distributing it through, so you can really just cross things out, and I think helps organize the work better. So we take that LCD and we multiply all the little fractions. We're multiplying the top of every little fraction to help organize it. That's not supposed to be a 5, that's a 4, of course. So the x minus 4 is crossed out, and I'm left with 3x plus 12 minus, both of those cross out, so we're just minusing 6. The whole fraction bar, 3x minus 12 and x plus 12, or x plus 4. So our like terms say that this is 3x plus 6, those two combined together. And here we're going to get 4x minus 8. It looks like we could pull out a GCF from that. But if you notice, it didn't really help. What? Hang on a second. We wouldn't have a 2 here. We'd have a 3. Because 3 goes into 3. 3 goes into 6 twice. Sorry, I wrote that wrong. What I have here, I did it again, didn't I? I've got to be able to distribute that back in to match what I have up top, and distribute this back in so I can match what I have on bottom. Now I look at this. There's nothing I can reduce. Nothing crosses out. So this is probably the best way for you to leave your answer. And we flip over to the other side. Now, this is a little craziness. Here we have a college student, and she drives home for the weekend. So if you can imagine, you're away and you're going to come home. You're going to drive 2 ways, home and then back to school. The distance between her home and her dorm room is D miles. Her average speed coming home is R1, and her average speed driving back to school is R2. So her average driving trip is given by this complex fraction. So her total time would be this guy right there. So if you think of distance equals rate times time, okay, that's an equation that to figure out a total distance, that is the speed at which you're traveling for the amount of time that you travel in. Well, if we want to figure out the driving trip, which is the time, we're going to divide by R. So distance divided by rate equals time. Now we have 2 different rates though. We have a rate for driving one way, and we have a rate for driving the other way. But that is just understanding what that's all about. Barely matters. So we have D over R1 plus D over R2. We're going to look for our LCD. So our LCD is R1 times R2. So we're going to multiply this R1 times R2 and R1 times R2, and we would also do it here. Multiply it to every term that we have. Here they cross out, here they cross out, nothing crosses out there because we don't have a denominator to cross it off with. So this is 2D R1 R2. Nothing crosses off. Here we get D times R2, and we get D times R1. Now, just for simplifying purposes, you see a D on top and you see a D on both sides of the plus sign. So I can pull this D out in front. So it's 2 times R1, R2 times D. And I can do my GCF, pull those D's out, and it's R2 plus R1. So my D's can now cross out.
I have a question.
So when we cross those off, we're left with 2 R1, R2 over R2 plus R1.
Mr. Weber, I'm a little confused.
All right, a little crazy, but there we are. Simplified it down. So if we knew our rate, we knew at which our average speed was, we could calculate what the total time was. Now it's one for you to try. You go ahead, try this, then come back and see how it goes. So here we're going to be looking for the LCD. Now there's a couple different ways we can think about this LCD. One way to do this problem is to think about it and we factor apart these numbers. So we have 2 times 5. That makes 10. There's no way to break apart 5, so we just have 5. There's no way to break apart 2, so we just have 2. And 4 is 2 times 2. So to figure out your LCD, you could say I need a 2. I need another 2 because this one needs 2 2s. I need a 5. And this one has a 2, which we've already pulled out, and we've already pulled out a 5. So a 2, 2, and a 5. Well, if you do the math to that, that's 4 times 5, which is 20. 20 is the number that 2 goes into, 4 goes into, 5 goes into 20, 10 goes into 20. That's the smallest number all of these values go into. Now, since we broke it apart and we did the other problems like that, you could still just say 2 times 2 times 5, 2 times 2 times 5, and treat it just like we did the other problems. It's probably stretched out that way a little bit, but 2's cross out, the 2 and the 5 get crossed out, the 5 gets crossed out, and the 2's get crossed out. So that's going to give us a 2x minus 4x That's going to give us 10x minus 15. So that would be negative 2x over 10x minus 15. We could factor a 5 out of that, but that wouldn't help us. So that would be our answer. That's one method way to write it. The other way to have done it right? The other way would have been just to multiply straight up with the 20. And you know that 10 goes into 20 2 times, so you got 2x. And you got 5 goes into 24 times, so you got minus 4x. 2 goes into 20 10 times, so you got 10x. Minus 4 goes into 25 times, so you got 3 times 5. So either way you want to think about it. This is probably really, that was our first one and this was our second one, but however you want to think about it, doesn't matter. Hey, you get the same answer. Now here we have denominator, or we have exponents that are negative. And if you have a negative exponent, that means that term wants to be in its own denominator. Because it's separated between the 4 with subtraction, we don't bring it to the bottom of the entire denominator. We just give it its own. So we have 4 minus 1 over k squared, 2 over k, because it's not adding and subtracting, so it goes in the denominator of the 2, minus 1 over k squared. It's not attached to the 2k, so it doesn't go into its denominator. Now we look for our LCD. K squared. K is acceptable to the k squared. This denominator is just 1, so it's happy anytime. And then k squared again. So k squared is your common denominator, LCD. So those would cross out. One of these would cross out. Those would cross out. And actually, none of these would cross out, would they? There's no denominator there. So we're going to get 4k squared minus 1. And here we're going to get 2k minus 1. Now, when you look at this, you have 4k squared minus 1. 4k squared is the difference of 2 squares. So actually, this can be factored apart. Which can be reduced, and it's just 2k plus 1. And that's why it's important to be able to reduce. Last one. So nice and simple here. This is the LCD. So we know that an x plus 1 is going to be part of our LCD, and x minus 4 is going to be part of our LCD, and this also needs x minus 4. So we don't need another one. We're fine with that. So our LCD is x plus 1, x minus 4. So we take that and multiply it to each of the terms. And by doing that, you can now start your eliminating. So then we're going to have 3 times x plus 1 and 1 times x plus 1 plus, you don't really need parentheses around that. You could. It makes you think like you've got to have it separated. All right, it's 1 times that. So you get x plus 1. And you get 3 times x minus 4. So that's going to clean up into 3x plus 3. Three times x is 3x. 3 times 4 is 12. That becomes 4x, and this becomes negative 11. You could pull the 3 out, but there's nothing for it to reduce over here. So that is a fine answer. All right, good luck with that.